Okay, this is an introduction to the laws of exponents. We've learned that how exponents work. If you see this 5 to the third power like this, 5 cubed, it means 5 times 5 times 5. And if you see 5 squared, it just means 5 times 5. But what if we multiplied these two numbers together, 5 cubed times 5 squared? Well, the 5 cubed is 3 5s multiplied together. The 5 squared is 2 5s. Altogether, you can count 1, 2, 3, 4, 5. There's 5 5s all multiplied together. But maybe you can see a shortcut for getting this answer. And I hope maybe you can just look at it. Well, all you'd have to do, instead of writing all these things out here, is just write down the 5 and then add the powers, add the exponents. 3 plus 2 equals 5, so it's 5 to the fifth power. Well, that's a really important law of exponents. When you multiply two terms that have the same base, it only works if they have the same base. You can write down the base and just add those exponents. Here I did a couple examples. So if you had 3 squared times 3 cubed, you'd write down the 3 and go 2 plus 3 is 5. Here we've got 2 squared times 2 cubed times 2 is 2 to the 6. Well, 2 plus 3 is 5. Why isn't there a 5 there? Because there's really a 1 here. There's another 2 getting multiplied. So 2 plus 3 plus 1 is 6. Here's 10 to the fifth power times 10 to the third power times 10 to the really is the first power. There's a 1 there. You'd go 5 plus 3 plus 1. That's 10 to the 9. 10's a nice number. If you multiply it by itself 9 times, there's 9 zeros. And a 1 followed by 9 zeros is just a billion. Okay, let's look at, there's another thing here. What if we divided 5 cubed by 5 squared? Well, another way of expressing dividing is using a dividing line. This means 5 cubed over 5 squared, which is really 5 cubed divided by 5 squared. Well, in the top we have 5 times 5 times 5. On the bottom, 5 squared is 5 times 5. Well, when we divide these two things, you might remember doing something like this. If you take this 5 and you divide by this 5, it really just equals 1. Anything divided by itself is 1. We say those two 5s cancel. And this 5 divided by this 5, it also equals 1. We say it's canceled. So you only end up with 5 times 1, which is 5. And maybe you can see the shortcut that will give this answer. When you divide two things at the same base, all you do is subtract their exponents. 5 minus 2 equals 1, which is 5 to the 1. Well, there's that. That's a really important law of exponents. So when you divide two terms with the same base, you write down the base and you subtract those two numbers. And that's how you get the answer. See, you had 5 to the 7th divided by 5 to the 4th. You write down 5, goes 7 minus 4, it'd be 5 cubed. That's really 125, but that's your answer, 5 to the third power. 9 to the 7th power divided by 9 squared. Well, that equals 9 to the 7 minus 2. That'd be 9 to the 5th power, which is some really big number. But here's a kind of a strange example. If you have 3 to the 7th divided by 3 to the 7th, if we go 7 minus 7, we get 0. But that exponent is kind of strange. What does 3 to the 0 mean? Well, we know that anything divided by itself is equal to 1. So 3 to the 0 must equal 1. Well, that's a big idea, actually. It turns out that anything to the 0 power is equal to 1. Well, that's enough laws of exponents for today, I think. So I'll stop there.